So the parent function that we're going to graph today is y equals k over x, inverse variation, which looks like this. If k is positive, the function is going to be in the first and third quadrant, because if k is positive and x is positive, then you're going to have two positives right here. And if k is positive and x is negative over here, you're going to be in the third quadrant. And there's also going to be, if y equals k over x, where k is negative, these two are going to be flip-flopped. So you're going to be in the second and fourth quadrant. So to graph, excuse me, this, you really want to consider the asymptotes. So remember, an asymptote is a line that a function can get very close to but does not cross. So here, your asymptote is going to be x is 0, because x can't be 0. So I'm going to do my asymptote in red. And then also, because we're looking at reciprocal functions, taking the case of something like this. Oops. I'll delete that. 1 over a x minus h plus k. So the vertical asymptote is going to be at x equals h, and the horizontal one is going to be at y equals k. So right now I'm not shifting left or right, so that's why it's x equals 0, and I'm not shifting up or down, so the asymptote is going to be y equals 0. So you're going to want to graph at least 3 points on each branch. So there's 2 branches. There's a branch in the first quadrant because this is positive, and there's a branch in the second quadrant, or third quadrant. So to get precise points, think of numbers that you can plug in for x. So if you plug in 3 for x, 3 divided by 3 is 1. So one ordered pair is 3, 1. You could plug in 1 for x. You could plug in 1.5, because 3 divided by 1.5 is 2. So 1.5 and 2. So I have these 3 points right here, and I'm going to curve them and connect them like this. So remember, your curve should not cross these asymptotes. So there's our 3 points, and now I can do negative. I can put in -1, so -1 is going to be -3. I can plug in -3 is -1. Oops, that wasn't it. I plug in -4. -3 is -1. And then I could plug in -2, so -2 is -1.5. And then I can connect them with the blue curve again. So blue curve should not cross the asymptotes. And then over here, let's figure out our asymptotes first. So I'm going to shift right 2, so it's going to be x equals 2. So I have this vertical line at x equals 2. And then I'm adding 4, so my horizontal asymptote is y equals 4. So what you want to do is you're going to want to plug in numbers to get points on your branches. So think about plugging in, I can't plug in 2, because then this, you can't divide by 0. So I could plug in 3. So if you plug in 3 divided by 3 minus 1 plus 4, so 3 divided by 3, or 3 divided by 1 is 3, excuse me, 3 plus 4 is 7, so 3, 7 is an ordered pair. So I go over 3 up 7, 4, 5, 6, 7 right here. And then you could plug in, I'm trying to think of ones that will make it easier for me. So if I plug in 5, this is going to be 5 minus 2 is 3, 3 divided by 3 plus 4 is 5. I could plug in, let's see, let's plug in just 6. So 6 minus 2 is 4, 3/4 plus 4 is 4 3/4. You can plug in whatever ones you want. So 5, I just want to make sure I get 3 on each branch. So 5, 5 is 1, 2, 3, 4, 5, up 5, right here. And then 6, 4 3/4. And then I have a blue curve. Now I'm going to want to graph 3 more branches over here. So I'm going to plug in 1. So if I plug in 1, 1 minus 2 is -1. 3 divided by -1 is -3 plus 4 is 1. So 1, 1 is an ordered pair. I'll plug in 0. So if I plug in 0, 0 minus 2 is -2. -3/2 plus 4 is 2.5. So 0, 2.5. And I'll plug in -1. So if I plug in -1, I'm going to get 3. -1, 3. And then I'm going to connect it and make a blue curve. Alright, so here's more to do. So I'm just going to talk about what the graph is going to look like. So this one's going to have an asymptote at x equals 0 and y equals 0. And because this number is positive, it's going to be in the first and third quadrants. And this one, the asymptote's going to be at x equals -1 and y equals -3. And then because this is positive, it's also going to be in the first and third quadrants, generally located. Now, notice that like this graph right here, I said it was in the first and third quadrant, but really it's hitting 2 and 4 as well. But this is what I mean by quadrants. Wherever these asymptotes are created, I consider this first quadrant, this second quadrant, third, and fourth. So that's what I'm talking about here. Now, these two are different because you're still going to have the same asymptotes, so x equals 0, y equals 0, but this negative is going to make it so now you're in the second and fourth quadrant. Same thing with here, you're moving over, the asymptote's going to be x equals -2 and y equals 4. But then you're also, this number is negative, so you're going to be ending up over here at something like this. Oops, there's my asymptote. There's my asymptote, roughly. It's going to look something like this. And then you can get exact points again by plugging in numbers. Okay, same thing up here, except for I'm going to look at number 5 down here. So now what's going on is you have this x squared. So what's going to happen with this x squared is no matter what, you're not going to get y to be a negative number. So where's y is not going to be negative is right over here. So your function is going to now look like something like this instead, your parent function. So your parent function of k over x squared, when k is positive, it's going to be in these two quadrants. If k is negative, it's going to be in these two quadrants. So you're still just going to plug in numbers right here. And in this case, your asymptote over here is going to be x can't be -3. Or x is negative, I don't know why I was thinking of restrictions, I was looking down here. But x is equal to -3 and y is equal to -1. And we know it's going to look in the shape of something like this. Just like over here. So you can plug numbers in to figure out the exact locations of the points. And the second part of the section is coming up with restrictions. So we did this a little bit in chapter 1, I believe. So Restrictions are when you're solving or simplifying, you don't want to have a 0 in the denominator. Remember, you don't want to divide by 0. So what you're going to do is you're going to look at your denominator and set that equal to not be 0. We don't want our denominator to be 0. We don't want to divide by a 0 because it's undefined. So you take your whatever your denominator is and you don't want that to be 0. And then you solve. Well, in this case, we already have x solved. It's just x can't be 0. And then number 9, excuse me, we already have our restriction. I mean, you can't do x can't be equal to 16. Or not x can't be equal to 16, but you can't do 0, 16 not equal to 0, because 16 isn't equal to 0. So in this case, there's no restrictions. There's nothing, you can put any number in for x, any real number. And y is always going to make sense, because you don't have a situation of dividing by 0. And then number 7, what I'm going to do is x squared minus 9 can't be 0. So this means that x squared can't be 9. So this means that x can't be 3 or negative 3. So it can't be 3 or negative 3. Two things. And then number 10, I'm going to do x squared plus 25 can't be equal to 0. So x can't be equal, x squared can't be equal to negative 25. Well, I can stop right there and see that there's not going to be any restrictions because this is going to be an imaginary number, and we're just talking about restrictions on real numbers here. So there's no restrictions. No restrictions. And then number 8, I take my denominator, and I don't want that to be equal to 0. So this is one where it's going to make sense to factor. So this factors into x plus 2, x plus 3 equals 0. This means that x can't be negative 2 and x can't be negative 3.